Thakur Vidya Mandir High School and Junior College welcomes all the 12th standard computer science students. We are going to learn the second part from Unit 5, that is networking technology, that is transmission media. So we are going to elaborate transmission media and its characteristics in this concept today. So firstly, what is a transmission media? Transmission media is nothing, students, the simple cables that we are using for connection. So if I'm saying a cable, there are different types of cable. Every cable has its own characteristic. Depending upon the type of network, we use different cables for connectivity. So we are going to learn about the cables. Before that, we are going to learn about the characteristics. So first, let me define what is transmission media. The pathways through which individual systems are connected in a network are called as transmission media. So, there are many systems. We are going to interconnect the systems together in a network, that is called as a transmission media. Transmission media makes transmission of electronic signals possible from one computer to another computer. Now, what is the main function of the transmission media? It is going to transfer your electronic signals from one computer to another computer, and the signals that we are going to use, it can be in binary pulses, that is either 1 or 0. It will be in binary pulses, that is either 1 or 0. 1 means high, 0 means low. So let me show you the different transmission media. So you can see we have here many transmission media. All are different from each other. Each and every media have their own specification, or we can say it has their own characteristics. Characteristics of transmission media: cost of the media, installation requirements, bandwidth, band usage, attenuation, immunity from electromagnetic interference. So these are the different characteristics of the transmission media. Now what are these characteristics exactly? First, let me give an example. If I am having a living room, I want to design a living room. I brought my TV, AC, electronic lamps, and a few more electronic devices. If I want to make the connection so that I can set the room, what I will do firstly, I will call skilled labor to do the connection. So when the skilled labor comes, what he does, depending upon the type of connection, wherever the wire is available, firstly he will give me the proper layout where can be the device fitted. Secondly, in order to fit the device and achieve connection, he will be using cables. So depending upon the network, that is my living room, the normal use cables he will be taking. So when he takes the cable, when he go to the market and purchase the cable, first he will see that the cable that he is purchasing is cheaper as well as robust. What does robust means? The lifespan of the cable should be more. Next, the cable that he is going to purchase will be only as per the requirements for the network. How much he require to design the network, that much cable only he will purchase. The cable he will be purchasing, he will see that the capacity of the cable will be more. Okay, the cable doesn't have any electromagnetic interference, so that we can use it for better thing. So these are the different things that he keeps in mind before designing the network. Sometimes some cables that we will be purchasing, for example, if I am taking a fiber optic cable, the installation, because for installing the cable we require separate connectors or adapters in order to cut the cable in order to make the connection. The cost of installing the network sometimes will be more than the cost of the cable. So here also there is a problem. So this all concept we are going to learn in detail in characteristics of the transmission media. Cost of the media. Firstly, let us discuss about the first characteristic. One major important factor is this cost. If I am going for a better technology cable, the cost will be more. So the network designer, whenever he is going to design any network, he will see to it that the cable that he is going to purchase, it is cheaper, as well as the lifespan of the cable is more. So the decision will be depending upon the network designer. If I am going for better technology, the cost will increase. One major factor in purchase decision of any networking component is its cost. For a fast technology, cost is also more expensive. Decision depends upon application and standard of the resources. Therefore, the network designer must settle for something which is cheaper and robust. Secondly, we have the installation requirements. The installation requirements. Here, as we discussed in the earlier part, sometimes the cable cost will be less. The designing, that is the installation requirement for designing the cable will be more because it depends upon different network. Some network are like that we don't require any skilled labors to install it. But some network just like fiber optic cable, if I'm using fiber optic cable to design the network, the cost of designing the network as well as the installation requirements, because we require skilled labors for connection, it increases. So firstly, we require the layout of the network. Secondly, the proper connection has to be done so that the data gets transmitted properly. Some transmission media requires skilled labors to install. As I said, it depends upon the type of network. This increases the cost of the network and it may cause certain delay. Therefore, before installation, we need to prepare the actual layout of the network. So, we require the actual layout of the network, students, before designing the network. Next, let us discuss about the bandwidth. Now, what is bandwidth? Bandwidth is, it's nothing, students. It is the capacity of the medium to transmit data. Each and every cable has its own capacity. Let me give an example. If I am taking a 45 minutes lecture, how will be your graph? Initially, when the lecture starts, the graph will be going a little bit from low, that is from low state, it will be going to the high state. In the middle of the period, it will be in a plateau state. And once the lecture goes on, what if I'm taking the lecture for rather than 45 minutes, if I'm taking it for one more 45 minutes. So what will happen? From the plateau, the graph will go down. So the exact plateau period is the proper bandwidth where you are fully concentrating on the lectures. So bandwidth is nothing. It is a capacity of a medium to transmit data. Let us compare this with the lecture. If I am taking lecture for 45 minutes, your concentration will be more. If I increase the time duration of the lecture, the concentration little bit decreases. So, smaller the distance, better will be the bandwidth. Larger the distance, the bandwidth decreases. Always keep in mind the data that is going to be transmitted will be always calculated in BPS, that is bits per second. We can also call it as a baud rate. Baud rate we calculate. Baud rate is nothing. The data that is transmitted in bits per second is called as the baud rate. Now let us discuss about bandwidth. Bandwidth is the measure of the capacity of a medium to transmit data. Data transmission rate is number of bits transmitted per second. Bandwidth of a cable depends upon cable length. A short cable have greater bandwidth than a long cable. So for all cable designs, maximum length of cable runs are specified. Whenever we are designing the network, whenever a cable is being purchased, we see to it that the cable has better bandwidth. This is the bandwidth. You can see here the plateau period. Up it is. Here is the plateau period where it will be having a better bandwidth. So you can see the plateau period is measured as the bandwidth. Beyond this limit, the highest frequency signals can deteriorate and errors occur in data signal. As I said, if I am taking the lecture for 45 minutes, the concentration will be more, and if I am exceeding the time, what happens? The concentration reduces. In a similar way, when the bandwidth is there, when a cable is transmitting a data, it has its own capacity. When I'm exceeding the capacity, a lot of errors will occur. Errors are nothing. The signals will get weak first thing, and noise. Some other signals will come ahead and interfere it, and it will make the transmission, it reduces the transmission speed. Next, let us speak about band usage. Bandwidth that has been given, bandwidth is always shared so that we can use it maximum thing. Bandwidth is shared so that maximum usage is obtained. There are two types of transmission modes. One will be the baseband mode and second will be the broadband mode. What is a baseband mode? If there is a bandwidth, if only one channel occupies the entire bandwidth, that is called as baseband. If in a bandwidth, two or more channels occupy and each is having a different frequency, that is called as broadband. Let us see. Broadband enables two or more communication channels to share the bandwidth of communication medium. Baseband is the most common mode of operation. In baseband, signaling can be on analog or digital. In baseband, the entire network, or we can say the entire bandwidth, is devoted only to a single channel. That is, in a bandwidth, only a single channel will be operated. Broadband, in a bandwidth, two or more channels will be operated. Now see, you can see here the diagram of baseband and the broadband. So see, in the baseband, there is a bandwidth, only one channel is occupied. And here we have analog signals. The signals can be either analog or digital. In broadband, you can see here, three signals are occupying the bandwidth. Okay, you can see some diagram of baseband and broadband. So you can see here, broadband, there are three signals which are being shared in the bandwidth. And here in the baseband, you can see there is only one signal used. Baseband, and here is the broadband. And in order to send the signal via the broadband and receive it at the other end, we use different technique called as multiplexing. There are different types of multiplexing: space, frequency, time, that we will discuss in the next class. Now let us differentiate what is a baseband and a broadband. Only one channel is transmitted on available bandwidth. Many channels are transmitted on an available bandwidth. Original information is directly sent online. Information is modulated and indirectly sent in different form. As I said, different form we are using in order to transmit the data, and we modulate it. Small bandwidth can be used because it is having only one channel. Big bandwidth is required to transmit more channels. Twisted pair cable is used for connection. Coaxial cable is used for broadband transmission. Now, what is a twisted pair and a coaxial cable? We will learn in the types of transmission media. Example of baseband is LAN or telephone line. Broadband is your TV cable. So by this, the concept of band usage has been completed. So keep in mind, what is a band usage? My bandwidth is shared so that maximum usage is obtained. Always we use broadband because via broadband a large amount of TV stations, radio stations as well as satellite links can be achieved. Next, let us learn about electromagnetic interference. Electromagnetic interference, that is immunity from electromagnetic interference. Now, what is electromagnetic interference? When a signal goes in a smooth way, if some other signal comes here and interferes, that is called as an electromagnetic interference. Just like my interrupt concept. So, whenever a signal is moving smoothly, when another signal comes ahead and interfere, that is called as electromagnetic waves. So, because some other signal is interfering, what will happen? The signal will become weak and we won't be able to decode the signal. So, the best example of your electromagnetic interference is the crosstalk. So, let us learn about electromagnetic interference. Electromagnetic interference consists of outside electromagnetic noise that distorts the signal in a medium. Noise is nothing, the unwanted signal. EMI is interfering the signal and makes it difficult for the computers to decode the signal. An example of electromagnetic interference is the crosstalk. Crosstalk occurs when signal from one wire is picked by another wire. In computer network, large number of cables are located close together. Therefore, crosstalk is a significant problem in network. Electromagnetic interference always arises when too many cables are crowded together. When we walk in the road, you can see near the post an ample of wires, TV, telephone wires, all will be LAN wires, all will be mixed up and together. When one person is working on the wire, if there is a problem in the wire, if the other wire is having a minor problem, what will happen? The electromagnetic signals that is coming from the first wire will be interfering the other and distortion takes place. So here the diagram shows analog signal and digital signal. So you can see I have highlighted here the noise. First, let us check about the analog signals. You can see in the first diagram, it is the original signal with the noise, and when it is being received, because of the noise, distortion takes place. Because of the noise, distortions take place. And secondly, we have here the digital signals, where you can see along with the digital signals, we have noise. So when we are using devices to rectify it, we get at the end product, that is the resorted digital signal, that is excluding. We use a device to filter up the noise, and we get the final digital signals. Always keep in mind, whenever there are many cables crowded together, there will be always a electromagnetic interference. There will be always a problem in transferring data from one device to another device because of the EMI, electromagnetic interference. Lastly, let us discuss about attenuation. If there is an auditorium which is fully occupied, if there is a teacher who is taking a lecture, what will happen? The students who are sitting, the teacher is taking without a mic. The student who is sitting in the front will be able to listen to the lecture properly. In the middle, whoever is sitting, the space will be reduced. At the same time, the student who is sitting at the last might be not at all able to hear what the teacher is saying. So what they will do, they will disturb, they will talk with each other, and they will create a lot of noise. How this can be overcome so that all the students pay attention by using a mic. The similar thing takes in attenuation. Whenever a signal is traveling through a medium, what will happen? Some of the signal will be observed and the signal weak. So whenever the signal is going to weak, what will happen? The other end, whoever is there, will be not able to listen. So the measure of how much a signal weakens when it travels inside the medium is called as attenuation. Attenuation is the measure of how much a signal weakens as it travels through a medium. As signal passes through the medium, part of the signal is observed and makes the signal weak. Attenuation decides the cable length. When signal strength falls below certain limits, then at the receiving station, noise may occur. As I said, whenever there is an exceeding beyond the limits, beyond the capacity of the cable, then there will be a lot of noise. Repeaters can be used to regenerate the signal. As I said, if the teacher is taking a lecture without a mic, the last person won't be able to listen, he will make noise. So how I can avoid it? By using a mic so that everyone pay attention. So your mic, what it is doing, it is going to amplify my weak signal into strong. The similar function my repeater will be doing. Whatever signal is been getting weak or distorted, it will amplify the signal and it will be transmitting to the other end. So here in this diagram you can see how the analog and the digital signal is getting distorted because it is getting weak as it travels inside the medium. See the corrupted signal, and when it is passed through the repeater, how it is getting regenerated signal. There's always a difference between a repeater and an amplifier, student. What does an amplifier do? No? Whatever signals is there, it will amplify and give it. The repeater will be amplifying noise also. So let us elaborate about the repeater in the next class. Further we have concepts, there I will elaborate about repeaters. So by today we have completed the concept of transmission media, its characteristics, and we have learned each and every characteristics of the transmission media. In the next class we will be learning about the different types of transmission media. Thank you, students.